Welcome back to real time digital signal processing lab. Actually, in the last class we discussed adaptive filters in MATLAB. Today we will discuss about adaptive filters in Code Composer Studio. So, we will see that one of the thing what I will do is, because we have one of the experiment, that is FIR filter noise cancellation using external inputs. Okay. This is from the book Real Time Digital Signal Processing by Ronald Ray, what I have taken the thing. So, which has the adaptive noise, that is 2 in IIR Interrupt Driven. So, that is left gets the noise and then the right channel gets the signal. So, using the IIR filter, the interrupt driven, what it the demo is, because the adaptive value for this is very low. So, you will be hearing most of the time noise and voice is going to be very little heard in the thing, because it has taken little time. So, I thought I will demo this experiment first and then go back to other experiments. So, what is it in this case? A desired signal and a reference noise signal to the input to left and right channels respectively, what we are going to put it in, and a stereo 3 sample jack, a 3.5 mm jack, what we will be using for inputting from the laptop to the board, that is the plug-in dual RCA jack plug cable will be used in this case. And a test input signal speech noise dot wave is fed through this jack, and this may be played through a sound card and input the kit via stereo 3.5 mm jack. So, in our case we are using My Music basically, and this is the speech noise what we will be feeding into the board. Build and we will be running this program and test it using this wave file. So, this adaptation will be taking place. The output on the left channel of line out should gradually change from speech plus noise to speech only, and it has to be adjusted with the volume at which you play the file speech noise dot wave. Okay. If the input signals are too quiet, then the adaptation may be very slow. That is what the thing. So, one has to look into these things. Going to the next slide. So, we will see that this is the adaptation thing, what it is being real time setup. So, line in gets the right that is signal, and line in left jack gets the reference noise, and you are using the IIR filter here whose weights are going to be controlled using the adaptive filter. So, you will have the signal plus noise what it is going to come, which is going to come out as line out R, and the error signal which is coming out of left channel will be output. And this is how you can look at the, what I will say is weights, basically how they are getting adjusted. So, from 0 how they will be going up, what we will look at the thing. So, coming to our Code Composer Studio, this is the file what we have it, that is adaptive 2 in IIR. So, what we have is this is the, it uses a bilinear dot coefficient. So, if I open the coefficient thing, so you will be seeing that A and then that is poles and zeros have been taken in this fashion. This is a third order filter what it has been used using MATLAB, and the cutoff frequency what it uses is a Chebyshev low pass filter with 2B passband ripple and cutoff frequency of 1500 hertz. So, when you design in the MATLAB, so you will be getting the filters, that is type 1, as I was discussing in IIR filter class, that Chebyshev 1 will have a ripple in the passband and then it has a steep cutoff in the stop band. So, the ripple what in the passband is used 2 dB basically, and these are the coefficients taken from the MATLAB, and then it will be using in our real time implementation. So, you are seeing that this has been loaded, and then the this thing beta, whatever this is the learning rate, in this case it can be alpha, beta, each one uses their own notation. So, what it is a very slow adaptation what it has been taken 1 e power minus 12. Okay. So, and then the length of number of adaptive filter weights what it is chosen is 128, and then you will be making variable weights and then your n, and then number of sections what you will be taking it with 2 basically, because you need both A and B coefficients. So, then you will be what you are going to get is reference noise you will be getting from the left channel, and then the signal is going to be getting from the right channel. So, that is how it has been recorded and then stored in the thing. So, we are going to have these two mixed, which is coming into our board, and then this is you will be inputting reference noise, and then you are doing the filtering here. Basically, you are calculating your yn output and you are updating your coefficients wn, and then you are putting input to yn. Okay. So, this is signal noise has both yn plus signal. So, then you are making it y of n is 0, and then you have the reference noise here, and then you will be computing your error basically signal noise minus yn. So, you are trying to reduce this error. So, and then you are calculating your weights n plus 1 weights basically here using this equation. This is your mu adaptation parameter, which is named here as beta, and you will be updating your x of I with the previous values. New one will be coming from the input signal, and output what it is going is both left and right channel has been put with error. Error has to reduce and then slow down. So, because if I rerun the code again, so it will be having lot of noise in the thing. What I will do is, because it has already been run for some time, so if you want you can change your beta value and then look at it. So, I had stopped the thing, I will be playing it and you will be hearing little voice and there will be little error. It will take longer time to adapt. So, still you are hearing the it will take longer time to adapt. Actually, still you are hearing the voice in between noise in this case. So, as you will be seeing that I have removed the thing from running basically. So, from the Code Composer Studio, still the input is going into the board and then it is running. Only when I reset the board you will not hear anything. So, this is the first experiment because it has lot of noise initially. So, now little bit of speech is coming, it takes longer time. So, what you can do with your codes, basically you can play around with a little more on your adaptation by changing the thing. So, one of the thing what I can do is I can make it 0.001 in this case. Let us see what is the thing is going to happen. I can store it and then I have to do recompilation again. So, it is telling that whether I have to stop the debug session. As you can see that here the diagram at the bottom, what you are seeing is the coefficients from some value what it is getting adjusted to. So, I will restart the thing, I will be stopping it and then taking it up. Okay, there was a little error in the thing. So, what I will do is I will stop the thing. The memory was not getting cleared actually. So, let us see, it is okay, some memory block, it has still a reading error. Let us see whether it is going to run. Okay, I will be playing the thing. In these cases, in what you have to do is you may have to restart your board by unplugging it and plugging in. So, although software reset, what I have switch is there, I have given the reset command, still it is not working. In that, what we do is we unplug and then plug the board, so that the complete memory is going to be erased. So, this is one of the thing one has to do it. So, just we will see whether it is going to have any effect on, because I have replugged my PowerPoint. Okay. Okay. So, even if this occurs, one has to take care is that no other go, you have to reboot the system. For the timing, let me see whether I can figure it out without doing that, with different experiment, whether I can come up with the thing. So, I can close this project and then restart the thing. So, the other experiment what I will do is, the first experiment will look at it which does not need the real time, this is the non-real time what we will see it. So, what we have is this is the adaptive filter LMS algorithm as a C program. So, it illustrates the following steps. What is it? For the adaptation process using the adaptive structure as shown here. Okay. This is our weight normal adaptive filter. So, I have the LMS algorithm in this case. So, weights are started with 0, y of n what I will be getting the output, and then this is the desired signal what I have given the thing, and then we will be subtracting error we are trying to minimize. This is fed to our LMS algorithm to adjust our weights. So, this is the equation what we will be doing it, that is y of n is nothing but W transpose n into x of n, and then E of n is nothing but d of n minus y of n, and our weight update W L of n plus 1 is given by this. Mu is the adaptive step one has to follow. So, L will be going from 0 to order of the filter L minus 1. So, by 1 repeat the adaptive process for the next sampling rate, what we are going to do the thing. So, how we are going to show the, even all of you with the simulator you can run this algorithm. So, how we are going to show that filter structure, the desired signal is chosen to be 2 cos 2 n mu into f divided by fs what we have it. Sorry, this should have been pi basically, sorry I cannot correct the thing. Pi into f is the frequency what you want it, and then fs, and the input to the adaptive filter is here also it is sin 2 n pi into f by fs, where this is the signal frequency f is equal to 1 kilohertz has been chosen, and sampling frequency f is equal to 8 kilohertz. The adaptation rate mu, okay. So, that is filter order n, you can change it from that is assumed as 0.01, and then 21 is the order of the filter, number of samples chosen as 60. So, we will 0 to small n is this thing 60 samples. So, we can plot this desired output, that is output y output and error, using tools, in this case graph and then single time in the Code Composer Studio. So, within a 60 sample instance, the filter output converges to the desired cosine signal. So, you can change the convergence rate, that is 0.02 from 0.01, and verify faster rate of adaptation and convergence. Okay. So, we will see the demo. What the book gives, these are the blocks. So, what we will do is we will go to this thing Code Composer Studio, and what I will do is I will remove because I wanted to show you how you can use the same thing to run your codes basically. So, I can remove these are the files what I have to remove from this. I will delete them, and then I can add from the code basically. I have stored in D directory in this case, wherever in your laptop you or computer you can store wherever you want to have the thing. So, we will see that these are the LCDK book files what I have taken the thing. So, in this case this is from the chapter 6. So, we will be seeing that this is the first code. So, I will copy this C file into my directory, or I can import this project from here also. Okay. So, one of the thing one can do it. So, we will import it and then put it here. I can do the paste, and then I will be do first I can do the compilation to see that I have any error. Okay. So, okay. So, there is a little problem in the thing, because this is on a simulator what it is going to run on. So, what we have to do is I can import the project. So, what I want is the CCS project. So, I will put it as next. I will browse from this folder. So, okay, I have imported it. This has become my active this thing directory basically. Let me see whether I am going to avoid errors in the thing. So, you will be seeing the errors, what are the things listed. Okay. Here it is telling that what it wants is V2CC XML active, what it has the thing. So, I have to open this, I have to remove this, because what I have for the board is sorry I can create a new. Okay. What I want is the target configuration file. So, I will be calling it as a new target configuration. So, in this case what I have is USB debug probe, what I have it, Texas Instrument, we have to check on the thing XTS 110, what I have it on the board. USB debug probe what to have it. So, one has to be careful when you are doing it real time, which is the debug port what you are connecting to. Okay. So, here it is what I have is LCDK 6748 board. So, I will save this configuration. So, those who have first time they will be doing the lab can discuss that how it has to be done. I will be giving the procedures and everything. So, now we will see whether by doing the this thing compilation whether my error is going to go. There are some of the errors which is coming in. What I will do is I will fix up in the next class and then come back and then tell you what were the problems with it, because suddenly what happened is my Active Directory got crashed and then I have to redo the thing. Some of the errors it takes little time, so which I will fix it and then I will be coming back in the next class. Thank you.